Opposite to this, we have the vibration theory of application. Scientists who believe So welcome everyone. Did you know that we smell thanks to frequencies? Or at least this is what the vibration theory of application suggests. But for the sake of this video, guys, let's just call it the quantum smelling theory. So in this video, we will scratch the surface of quantum mechanics, and also we will catch an eye on the enormously debated topic of quantum smelling. Quantum mechanics is dealing with the science of the incredibly small and actually the reality of the incredibly small. And that was born back in the beginning of the 19th century, thanks to an amazing scientist named Max Planck. Physicists didn't understand why the light in the light bulb only get to red, then with more energy, orange, and then yellow, and finally white. Because at this time, light was believed to be a continuous wave. So the question was up, why didn't it get bluer? Or more precisely, why didn't it start to produce ultraviolet radiation? So what Planck realized is that light is not actually a continuous wave, but it is a specific amount of energy or quanta of energy. Later on, a pretty well-known physicist, Albert Einstein, realized that light is built up of small particles called photons, similarly as electrons are built up. So, light isn't a wave, but it has particles. It's that easy, right? Obviously not. In fact, light or photons and also electrons have a wave-like behavior as well, and it is proven by a very famous experiment. So today's physics agrees on the fact that electrons and photons are neither particle nor waves until an observer sees it and it is decided what it is and where it is at that momentum. So you can imagine this: we spin a coin, and while it's spinning, it's both head and tails. And when an observer, or actually somebody, just stops that spinning, then it is decided, for example, to be heads. This is what's happening with electrons as well. Modern physics describes the position of electrons at a momentum with wave functions. These wave functions show the possibility of a particle being somewhere at a certain time. It's like we spin the coin around the nucleus, and while it's spinning, it's both head and tails, but when an observer stops it, it actually decided to be either heads or tails. And actually, with electrons, this shows the position of that electron. Very importantly, wave functions have frequencies as well. So far we have this weird wave function with frequencies. These are connected through quantum entanglement, which I won't get into in this video because it's very complicated and it needs its own, so stay tuned for that one. As you can see, the quantum realm has its own rules and it produces another weird effect called quantum tunneling. This is the quantum mechanical phenomena when a particle can propagate through a potential barrier. And now you can just think of the previously mentioned experiment with electron shooting. This phenomena led Le Catherine to believe that quantum mechanics can explain the way of our smelling, as the previously used shape theory was proven to be wrong. Okay, so you are most probably confused as for now, I promise. The shape theory is the older and more accepted perception of our thinking on the working of our nose. The theory suggests that molecules get into our nose by sniffing have an attractive and repulsive interaction with the receptors of our odorant, triggering smelling. And these interactions are in connection with the chemical features of that specific molecule, such as shape or size of whatever you are smelling. So, it is often referred to as a lock and key mechanism, meaning that the molecule getting into your receptor is like a key opening a door. It opens the signal that triggers smelling. And then the door, or actually the receptor, identifies what kind of molecule tried to enter. And finally, the brain creates that specific smelling. It is arguably flexible because it can be dependent on size, shape, and molecular bonds. Opposite to this, we have the vibration theory of application. Scientists who believe it debates the practical working of the shape theory, as according to it, two identically shaped and sized molecules should have the same smell. But in practice, we found molecules having separate smells with completely the same shape and size. So there has to be another factor which we haven't counted in yet. For instance, ethanol and ethanol having the same shape and size with one atom difference, and the former smells like vodka and the latter smells like rotten egg. This is when the longly explained quantum mechanics can supply a possible answer. Leading scientists like Luca Terrain set up an experiment with hydrogen and deuterium. They both have the same size and shape, just deuterium is a heavier isotope of hydrogen, meaning it has an extra neutron in it. Even more importantly, they have different frequencies. Firstly, it was tested on humans and then on genetically modified fruit flies, which have more distinguished odorant receptors. But honestly, no matter with who or with what kind of animal we do the experiment, the result is the same. They could smell the difference of hydrogen and deuterium, which opens up the space of the quantum mechanical explanation, as they have different frequencies. So, when molecules are locked into the receptors, they should trigger the brain. And it does in this theory as well, but it does it with vibrations. When two molecules vibrate on different frequencies, they should have different smells. It's like one molecule is the first string of the guitar, and when you play on it, it has a certain sound as it vibrates. And then you play on the second string of the guitar and it has a new sound. So theoretically, our nose works the same way as our ears do. Those vibrations can get to the brain with a different mechanism, as we are locking a direct electric connection and barriers unpresented. It's like we have two pipes, but we do not have a lock, so we cannot connect them. As a result, water cannot flow. This is when quantum tunneling does its job. The odorant receptors bring the vibration frequencies to the brain by propagating through chemical and biological particles. We could imagine this as teleportation. We still have two pipes which still cannot lock together, but now from the first pipe, water can get into the second pipe. To sum it up, we could imagine the quantum smelling theory. With molecules getting into our nose, it locks into the receptors and it starts to vibrate. Finally, just like electrons were shot toward the wall, it gets through every barrier, reaching our brain with a certain frequency, creating a specific smell. The theory of quantum smelling is very contrary, and a lot of scientists argue with it. You remember I told you the lock and key mechanism is very flexible. And according to other scientists, The different smell of hydrogen and deuterium could also happen thanks to different bonds they have. But what would be really appreciated is you bonding to our channel, because this is the end of the video, and even though we are not sure in either of the theories, we can surely say that quantum mechanics puts biology, chemistry and all the scientists into a new perspective, which I found fascinating. And if you enjoyed this video, then be sure to subscribe and hit us a like. You can also follow us on Facebook, Instagram, TikTok, and see ya the next time.